This is a very common question. App services versus AKS. I will give you few advantages of using app services over AKS, but that does not mean AKS is a bad service or should not be used. The choice of technology is always done by doing many considerations, cost, requirements, and fit to purpose study. I specifically got inputs on my LinkedIn asking for choices, which makes it easy for the adoption of app services against AKS. So I will be covering important points related to app services, which makes them easy to adopt. Hello and welcome all to my YouTube channel, Azure Beyond Demos. My name is Kunal Chandratre. And with this introduction, let us directly have a view at app service versus AKS. Let's start. Operating system updates. For Azure Kubernetes, the OS updates of Node is required. In case of app services, you deploy app service plans and you don't get access to behind the scene app service plan machine itself. Therefore, there are no operating system updates required for app service plans. In Azure Kubernetes, if you see here, there are two types of upgrades. One is Kubernetes version upgrade, okay, and another is the Node OS updates in the section planned updates. So planned updates are required for your Azure Kubernetes, but in app services, there is no such option because it is not needed itself. What you see on my screen is upstream Kubernetes codebase. Kubernetes is open source software. So whenever upstream Kubernetes version is updated, it is mandatory for every company to upgrade their Kubernetes version. So it is applicable for AKS as well. For app services, there is no such upgrade required for the underlying platform. So, no OS updates for app services or no platform software updates required. In the AKS version updates are usually done with zero downtime. When you trigger an upgrade, AKS creates new node with target Kubernetes version. It trains the workload, means pods and services are removed from the old nodes, and then it deletes the old nodes. So there is no downtime in reality. However, AKS version updates are planned with downtime and during off business hours. This means your operations team might have to work during non business hours or weekends, and this thing is avoided in app services. So there is no operating system update required for app services. Uh, well, it is required, but it is completely managed by Microsoft on their predefined schedules. In Kubernetes, you can decide the schedule, but in app services, you can't decide the OS update schedule. That's the major difference. Let's move to the next point. Language and runtime updates. So here I'm talking about language framework upgrades such as .NET Core 4 to 5, Python 7 to 8, Java 11 to 12, and so on. On the Azure Kubernetes side, you need to update the container image itself. For app services, it is just a drop down change. So this also means that if a version of Python is not present in the drop down and if I need it, I can't run it on app services. Whatever versions that you see in the drop down, only those will be supported. So tomorrow, if app services announce deprecation of a specific version, I will need to make sure that my application is compatible with the new version of that language. All right. Now let's talk about the scaling configuration in app services and AKS in detail. When I configure the horizontal scale in Azure Kubernetes, uh, I can scale individual pods based on my application. For example, if this is Node 1, which has 8 cores and 16 GB RAM, and let's say I'm running 3 pods or 2 pods of application A and one pod of application B. Now, let's say depending on the scale, I want to, depending on the need, I want to scale my pod, let's say A. Okay, then if there is a space available on this node itself, then few more pods of application A will be created. As soon as there is no more space on node 1, my pods will go into the pending state, and whenever it is in pending state, then automatically Kubernetes will create another node, node 2, of same size, 16 core, 8 core and 16 GB RAM, and then it will scale my uh, application pod A. This is how horizontal scale in general at very high level work in Azure Kubernetes. Entire app service plan that scales. Say, for example, if you're running an application and if you move that application into a standard or premium plan, and after that, let's say you configure the horizontal scale operation, then it is the entire plan that scales, not the individual application. So if you are running multiple applications inside an app service plan, all applications will scale. But now with the recent updates, you can also scale individual application, but that is not like AKS where individual pods of application are scaled, but it is still the entire app service plan that will be created, wherein only the required application will be scaled. That is how horizontal scaling works in app service. SSL custom domain in app services, it's very easy. As you see on the portal, you can configure the custom domain and certificates for your app service. In case of AKS, you will have to write the YAML code to configure the SSL and custom domains. In case of AKS, when we talk about the components of service, there are many components that constitutes AKS. So we talk about pods, nodes, services, ingress, container registry, and so on. But in app services, it's just very simple and plain. It is just app service plans and you're done. Azure Kubernetes is an API server offered as a service. So essentially, there is a control plane which is managed by Microsoft, and then inside your Azure subscription, within that you will have your own VNet subnet, and within that you will actually run your AKS worker nodes or AKS cluster. This AKS cluster will always need a connectivity to this control plane or master server or API server. All means same. Plus, if you want this connectivity privately, then it adds more complexities to networking. We don't need any such connectivity to control plane in app services, and it is very straightforward. Let's talk about networking. In app services, network configuration are simple. So you need a subnet, and in this subnet you will configure the private endpoint. Then you will have your actual app service. So this is used for the inbound traffic, and then you will create another subnet and you will configure the VNet service integration, VNet integration with this subnet, and this is used for outbound traffic. That's it. This is the simple configuration of app services in terms of the VNet. Now for AKS, there are many options like CNI overlay, Docker bridge IP address, KubeNet, and so on. So if we see the calculation of network subnet for app service, it is simple. Whereas for AKS, we need to calculate the subnets considering number of nodes, their upgrades, and count that might increase. Then CNI overlay based IP range for pods, number of services, load balancer IPs, and so on. So there are many aspects we need to consider for AKS networking subnet calculation. Plus, with AKS, every worker node will need communication to the API server. While this communication between AKS API server and worker node never goes on internet, it stays always on Azure backbone. But based on your audit, security, and compliance requirement, you might want access to this API server over a private IP. So we need to configure fully private cluster along with API server VNet integration based on the scenario and need. We might have to disable the public endpoint completely and then configure the required DNS entries accordingly. So in terms of AKS networking, it is really complex as compared to the app services network configuration. Next point is about open source software deployment. So in app services, you do not need to use any open source software for any functionality. But in AKS, you will often end up using many open source software like Helm, Nginx Ingress Controller, Kong Ingress Controller, and so on. Then, when it comes to monitoring the infrastructure for app services, the option is easy. It is the native Azure offering, which is Azure Monitor. You can integrate with third party tools also, but those options are limited to New Relic and App Dynamics, is what I'm aware of. But for AKS, there are many options to monitor the infra of Azure Kubernetes. Along with Azure Monitor, you can use Prometheus, Grafana, Container Insight, Elasticstack, Datadog, New Relic, and so on. When it comes to monitoring the application logs, it is very simple for app services. You do not need to write any code for, let's say, Java or .NET or Python application logs, because with App Insights, you can have no code integration for the application monitoring. But no code integration for AKS is not available today, and you will have to write code in your application to capture the application logs. Monitoring dashboards. So with application insights, you get ready-made dashboard for application logs, and with Azure Monitor also you have some shape and form dashboard available for monitoring of app services. For AKS, you will have to build the dashboard depending on the tool you are using. So if you are using Azure Monitor, you will write monitor container insights queries in Gusto language. If you are using Event Hub with ADX integration for AKS monitoring, you will have to write ADX queries, which is again Gusto based. If you are writing or using Grafana, then you will have to write or build your dashboard in that, and so on. When it comes to the portability to multi-cloud, because if you see many organizations are trying to embark on multi-cloud journey so that they don't have dependency on a single cloud. But if you are running your application on app services, I will say it is somewhat tightly coupled with Azure. But with Azure Kubernetes, as everything is container based, you can run your application either on premises, on Kubernetes, or on any other cloud on Kubernetes, or you can simply run it as a container. Uh, Remember, I'm talking about portability at the container level. So in your AKS application, if you are using Azure Blob Storage and now you want to run your application on AWS, then the equivalent of Blob Storage will be S3. In other words, you will have to change your code. Okay. So when we talk about portability, you will have to really careful in terms of which services you are using. On internet or public call. So for PV3 instance, as per documentation, it is 8064 outbound concurrent calls, and you can achieve even greater outbound public calls with VNet integration and configuring NAT gateway on top of that. For AKS, per VM limit is very high for outbound internet call, and again, it can be scaled using the same NAT gateway approach. Flexibility to run older frameworks with app service, obviously no. Whatever you see in the configuration drop down, you can run only those frameworks. With AKS, you can run any framework, any version, because the entire dependency to run your application will be present inside the container itself. So you there is no such restrictions in running the older frameworks with AKS. Learning curve, obviously with app services, it's very low, but based on the current discussion you have heard from me, definitely the learning curve for Azure Kubernetes is really high. Container lifecycle orchestration. So when you run the app services with containers, they run as a standalone entity, and they might use Docker Compose behind the scene. There is no orchestration in app service for containers. In case of Azure Kubernetes, the orchestration is really very matured. Then next point is about running multiple language based application. So I can use same plan, same app service plan, but if I have application made of, let's say, JavaScript, .NET, and Python, I will have to use different app services. Okay, I can use the same plan, but app services has to be different. But in case of AKS, I can run any language containers in the same AKS cluster. I don't need to change node pool or cluster to use multiple language based application. Right, with this, let's move to my favorite part, real world queries on this topic. So I have received uh, three queries on my LinkedIn, and I've decided to cover those in this video. So the first question is, if I have decided AKS as an organization strategy, then also I should adopt or use app services. Well, my answer is no strategy is always right, and it must evolve with time, change management, market adoption, and requirements. I've seen people using AKS for very simple application where it might be an overkill. So, decision to use AKS just because it is my organization strategy may not be right. Rather, you should update your strategy depending on the need, and wherein you can adopt AKS as well as app services together. So, always choose wisely. Next question. I'm building microservices based applications. So, still, I should use app services. Microservices based application can run on VMs or on app services also. It is just that container based deployment makes it easy. So just because I am having microservices means I have to use AKS may not be the only criteria for choosing the AKS versus app services. So I hope this clarifies. The third point, what if I want to migrate from app services to AKS? Well, if you're running containerized application on app service for containers, then AKS migration is comparatively easy. If you are deploying your code base on app services, then first you will have to convert that code into a containerized application and then migrate to AKS. Well, folks, thank you so much for listening me so patiently. That's all for today, and see you soon in the next video.